Okay, let's go.
I think you should start, yeah.
Yeah. Okay, so so I think we'll make a start. So my name's James Woodcock. I'm a research fellow here working on the S3A project. And we're going to present some work that me, John, and Rick have been developing over the past year or so. And this idea of media device orchestration. So I'll kind of talk a little bit more kind of in the presentation about what that actually means. But it's basically the idea of kind of using kind of devices that might already be in the room to augment an existing audio setup. So things like phones, Bluetooth speakers, things like that. This is all kind of enabled by this idea of object-based audio. So I don't know if people are familiar with the concept of object-based audio? No? Okay, so yeah, I'm going to go through kind of what that means. I'm going to talk a little bit about the S3A project, so kind of what the main goals of that are and kind of what's been going on. We're then going to present this media device orchestration idea. And finally, we've got a couple of demos. So we've got a demo in the listening room, which we're running in 20-minute slots from 1 till 3. So there's kind of potentially six people can be in any of those slots. So if anybody wants to sign up for a slot, then you can do so with this link, which is also on the board when I go past the slide. So if anybody's interested in seeing that. And then hopefully when I've finished talking, we'll have an incredibly experimental demo in this room that we've only just got working maybe 15 minutes ago. So there's the high degree of possibility for humiliation, but but yeah, hopefully it'll work. But that's going to involve kind of people connecting to a local Wi-Fi network in the room. The name and the passwords for the network are the same, so it's seminar Wi-Fi. So yeah, I mean you could connect to that now if you like, but then at the end of the talk, kind of we'll go through how we're going to run that demo. So hopefully I'm going to try not to talk for too long, because I think the demo could potentially be interesting. So we'll crack on. Okay, so what's object-based broadcasting? So I think we're at the beginning of kind of transitional periods in broadcast audio. So there's been kind of rapid developments in the past 5 or 10 years in terms of formats and delivery methods that are now offering kind of the possibility to distribute immersive and personalizable experiences to a wide audience. And kind of one of the main drivers of this change has been this idea of object-based broadcasting. So the way this kind of differs from traditional broadcasting is that kind of all of the individual media assets are kind of broadcast separately to the end user, so the listener or the viewer at home. And then those individual objects or assets can be reassembled at the listener end. So this means that we have the opportunity to kind of optimize how a piece of content is reassembled, depending on things like the viewer's preferences, perhaps their needs. So they might have some certain accessibility needs, like a hearing impairment that we can compensate for, or even the kind of environment that they're viewing the content in. So we can potentially put the content together optimally for different reproduction systems or different rooms. So yeah, so this is kind of how traditional broadcasting works. So the kind of media assets are assembled in the kind of normal way, but then that whole thing is kind of rendered down to one kind of fixed piece of content. So this might be a television, content's optimized for a television and a stereo reproduction system. The same thing is then kind of packaged up and broadcast to everybody, and then it's played back on a whole bunch of different devices, resulting in a fantastic experience for the television and stereo system, but it's a kind of compromised experience on different devices because it wasn't optimized for that. What happens in object-based broadcasting is the program's made still in pretty much the same way. However, each of those individual assets is kind of turned into a collection of media objects, along with some, and I think the vital thing here is some metadata kind of describing how to reassemble that at the listener end. And then it's up to the device in the viewer's home to kind of reassemble those objects according to the metadata. But that does mean that we can do that reassembly kind of intelligently if we have, some knowledge of the reproduction device or the environment. So what does this mean for broadcast audio? So I think kind of one of the main advantages is that we're no longer tied to a specific reproduction system. So we no longer have to produce content for stereo or 5.1. We produce it in this object-based way, and then it's up to the rendering algorithm on the other end to decide how to put that together for the system. We now have things called audio objects, which are generally defined as some audio data, which is the audio that each sound source in the scene produces, and also the metadata, which is information necessary to render the scene. So you can imagine for each object, you have some metadata that says, okay, what's its relative level in the scene, what's its position, and perhaps some more kind of semantic description of, okay, what's its purpose in the scene? Is it dialogue? Is it on screen, off screen? Things like this. And then that information can be used at the listener end to put that content together. In terms of what the producer or sound designer does, they now mix a scene kind of using something that looks like this. So this is kind of plan view of a scene. There are like 60 audio objects there, and the producer can move these objects. The yellow squiggles are the kind of automation tracks for those objects, and then kind of when they're happy with the scene, all of that kind of gets written out to some format that kind of captures all of that metadata and the objects. So I think the main kind of advantages of this approach over the kind of traditional methods are, well, firstly scalability. So we can take the same scene and potentially render it to any reproduction layout or device. So it doesn't matter, if it was produced in a 3D audio system, we can then use the metadata to do a sensible rendering down to stereo or like a headphone mix, for example. There's also the potential for interactivity. So because we've got all of the bits at the listener end, then the listener can potentially interact with the metadata, so they can set levels or positions depending on their preferences, for example. There's a big advantage to accessibility, so the content can be optimized for the different needs of the listener. And also it's potentially a more efficient representation than channel-based audio. So rather than having to send channel feeds for 3 or 4 different systems, you just send your objects and some metadata, and then they can be used to render to those different systems. And the rendering is usually done, so over loudspeakers, we often use VBAP rendering, which is basically panning between triplets of loudspeakers. But because we have individual objects and metadata, we can also render those scenes out to either to binaural or to perhaps systems like wavefield synthesis, which I guess some of you will have seen in our listening room. Something that we've been looking at on the S3A project, we also have the opportunity to incorporate things like listener tracking. So if you've got a Kinect in your room and you know where the listener is in the space, then we can kind of steer the sweet spot of a stereo rendering, for example, based on where the listener is in the room. And we also have the ability to kind of adapt to non-standard listening environments. So if we know exactly where the speakers are in the room, then we can adapt the rendering accordingly. So I mean, at the moment, this is still in the stage of something that's been developed in research labs. Although, I mean, in South Korea, they're planning to broadcast the Winter Olympics?
Yeah.
I think. So yeah, the Winter Olympics in South Korea are going to be broadcast using this object-based approach. But there have been a number of kind of experimental productions that the BBC have put out using object-based audio. So this first one was an example of a football broadcast where the listener could change the balance between the commentary and the crowd atmos, and they can also decide whether the crowd's atmos was coming from kind of the Watford end of the stadium or the Crystal Palace end of the stadium. So you could kind of optimize the experience you were getting depending on which team you supported. There's been a recent production from a project the BBC are involved with called Orpheus, which allowed you to, so it was a drama scene, and it allowed you to change kind of your perspective within that scene. So there are 3 different perspectives, so you've got a different experience of the drama. I think that's still up on BBC Taster, if anybody wanted to see that. It's called Mermaid's Tears. It's been so this approach has been used to develop kind of variable length documentaries. So you can kind of choose how long you want to spend listening to a documentary, and the content will adapt accordingly. So if you say, okay, I've only got 10 minutes, then it'll just give you the kind of important parts of the story. If you say, okay, I've got a full hour, then it'll play the whole piece of content. And there's also been some work trying to incorporate kind of information about your location. So the kind of content adapted, whether if you were in Manchester, it would kind of put things into the story about Manchester. If you're in London, it would put things into the story about London. So they're kind of some of the ways that this has been used by the BBC. There's also a spin-out company from Salford called Salsa Sound that Rob Oldfield and Ben Shirley are involved in. They're using object-based audio to improve the experience of football sound. So kind of localizing and pulling out the ball kicks and whistles and using that to kind of improve the experience. And also within the S3A project that we're working on, we've done some kind of object-based production, mainly to kind of research the workflow and for us to have some kind of material that we can use for test stimuli and testing systems. But that was actually one of those scenes which you'll hear in the demos today was actually taken up and turned into a piece of VR content called The Turning Forest, which is available freely on Google Play. And again, the reason why that was possible, why that audio was able to be used in this VR production, was because it was in objects. So we could just port the objects and metadata to Unity or whatever the visual artist was working in, and we were able to kind of port that audio over to kind of a completely different system. So obviously it's VR, it's in binaural. The original productions were over loudspeakers. So hopefully that kind of gives you an idea of what what object-based audio is all about. So this approach is kind of one of the main focuses of the S3A project. So the S3A project is a 5-year EPSRC funded project involving Salford, Surrey University, Southampton University, and BBC R&D. And the kind of headline focus of the project is kind of how we can use this object-based approach to improve the listener experience of audio, but in home environments. So we're really kind of focused on what's possible in the home. I've just said that. So there are basically kind of four streams of the project. So there's one stream looking at object-centered production. So what does the workflow look like in this kind of new object-based world? There's a stream looking at reproduction that's mainly been led by Southampton University. So once we've got the objects, once we've got a produced scene, how do we do the rendering to different speaker layouts? There's a stream looking at audio-visual capture, so that's mainly Surrey University. So how can we capture the scenes? How can we use microphone array techniques to kind of isolate and pull out audio objects from a complex scene? And then the stream that Salford and Surrey are involved in is the listener experience stream. So how do we kind of evaluate listener experience? How do we kind of optimize the reproduction based on factors related to the listener? And kind of the reason I put that in yellow, other than it's what Salford are doing, is that we're trying to make sure that everything, all of the technology development is informed by the listener, so by perceptual factors. So what's the benefit to the listener? So some of the things that we've done in this listener experience stream are trying to find out kind of what attributes are important, what perceptual attributes for the perception of audio and spatial audio. We've kind of looked at cognitively how people categorize complex objects in complex scenes to perceptually inform the development of metadata. And we've been looking a lot at, so Jan, if you can't see it, but we've been looking a lot at how we can use this object-based approach to improve speech intelligibility. Okay, so as I say, one of the main drivers of S3A is what can we do in people's homes. So quite often the outcome of these of spatial audio projects is that you need to get the optimum listening experience, you need this kind of highly controlled environment with like 150 loudspeakers surrounding the listener, and the listener's in the geometric center of the room with their heads not moving, which is kind of, it's unlikely people are going to install a full wave field synthesis system in their own home. I mean, it's pretty unlikely that people are going to install a 5.1 system properly in their home. I mean, everybody's somehow involved in audio and acoustics here. How many people have a spatial audio system at home that's properly set up? Is that one? Yeah. So if we can't get, if the people who are involved in audio research aren't going to install a spatial audio system, then we've not got much chance with the kind of general public. Also, people consume audio in many different environments over kind of many different devices. So this is probably more likely, what you would get in the home. So we've got kind of one speaker, a laptop, and a television, not placed in ideal spaces. There's a baby in front of the speaker absorbing all the sound from the right channel. No good. People share headphones on the train. Some people might have a high-end home cinema setup, or some people might want to consume content on their tablet over headphones. So kind of what we're interested in S3A is kind of how we can optimize or improve the listener experience in these kind of diverse scenarios where we've got lots of different devices and it's relatively uncontrolled. So this is what's kind of led us in the project to this idea of media device orchestration, which we're going to hopefully demonstrate today. So our kind of argument is that only a very small percentage of the public are willing to buy a surround sound system. From the percentage who do actually buy them, only a small percentage of that will have them properly set up and calibrated. However, most people will already have kind of speakers, multiple speakers in their home in kind of wirelessly connected devices. So things like mobile phones, tablets, laptops, smart TVs. If you think about the number of loudspeakers in your home, you'll probably be surprised how many are already in there. So so what we're interested in this idea is what can we do if we can kind of address and synchronize those devices. So if we can get access to the devices that are already in people's homes, then how can we improve the experience over something like a standard stereo system? And again, all of this is enabled by object-based audio. So because we've got objects, if we've got a listener and they've got a nice soundbar, but they've also got a phone and a Bluetooth speaker in their home, then perhaps we can use those discrete speakers to kind of redistribute some of the objects to those additional devices, still synchronized with the main kind of soundbar reproduction. So that's the kind of the concept that we're interested in and what we're hoping to demo to you guys today. So I'll just kind of quickly go through how this concept has developed, and then we're going to try it out live in the room and see what happens. So this concept came out of a kind of Hack Week event that we had at the BBC, where we were exploring a concept that we were calling playing the room. So the idea was that we could potentially route an object in a scene close to a physical object in the room that kind of corresponded to it. So if there was a door knock in the drama, we could say, okay, where's the closest speaker to the door? We'll route the object to that, which is quite cool. But we kind of realised quite quickly that was fairly gimmicky. But what was good about that idea was that we could kind of pick up these additional devices that were already in the room. And we found it offered a much more kind of immersive experience over the standard stereo rendering. So this concept was kind of developed over the next year of the project. So it really became a lot more about kind of this kind of Internet of Things type approach. So how can we address additional devices? And ended kind of at the end of the last project here with so this kind of it's like project jargon, but this challenge 4 system. So that was basically us in the project looking at how we can kind of intelligently use object-based audio to improve the rendering. But basically, what we got to at that point was a system where we had stereo. And then 4 additional Bluetooth speakers in the room that we could dynamically kind of redistribute objects to. And that's what we've got set up in the listening room demo this afternoon. So you'll be able to kind of switch between the scene being rendered just to stereo, and then the objects popping out of the scene into additional devices in the room. So that's kind of where we got to at the end of our last project here. And then kind of what we're doing going forward is to look at how we can actually do this wirelessly. So how can we as a technical review, so what are the technologies available that will allow us to actually redistribute objects to the devices people have in their pockets. So that's hopefully what we're going to be able to show working in this room after I've finished talking. What we're also doing, which I think is quite exciting, is we're commissioning a new piece of content. So we're going to be working with some professional content producers and the BBC to commission an entirely new piece of content for this concept. So we'll be asking a writer, what could you do with a story if you could address people's devices in the room? How would that enhance the storytelling? And then we'll be asking a sound designer to actually make that content and to experiment with how would you mix a piece of content for a system like this. And as part of that, we'll be developing the tools necessary for that content creation to happen. And we're also planning to do some perceptual evaluation of this system, which I'm sure we'll try to rope some of you into as participants in the next couple of months. And then, yeah, finally at the end of our project year, so in second quarter of 2018, we'll have this fantastic new piece of demonstration content, which we can hopefully, maybe come back and do another seminar on that production process and play you that content. So I've just got one more slide, then we'll try the demos. Oh, my picture's disappeared off that. If you imagine there's a picture of a listening room here with some speakers. But this is basically a system diagram of what you're going to see if you sign up to the demos in the listening room. So yeah, I think I kind of said this, but the demonstration is going to be a 2-channel stereo reproduction, augmented by kind of 4 additional Bluetooth speakers. There'll be kind of 4 pieces of content you can listen to, so you kind of see the effect this has on. So firstly, so 2 of the drama scenes that we produced as part of the S3A project, so radio drama. There's then a pop track, so you can kind of listen to what happens to music when we do this processing. And then there's also a radio advert. So we've got kind of a whole bunch of different content types, which all contain kind of a variety of different audio objects. In terms of kind of technically how it works, the object-based scene is stored in something called an ADM file. So ADM is audio definition model, which is an open format for storing both object-based and channel-based scenes. I think you can do scene-based as well, so you can store higher order ambisonics. But it's basically a multi-channel WAV file, and then an XML structure that's embedded in the header of that file that contains all of the metadata to kind of reconstruct the scene. So we've kind of got everything in one place. That's then kind of, so the audio from that file is routed to a rendering algorithm or a piece of rendering software that's been developed as part of the S3A project. Along with the metadata necessary to put the scene together. And that metadata is kind of passed through this adaptation framework, which allows us to kind of dynamically redistribute the objects to the additional devices that are in the room. That'll probably be clearer if you come down for the demo. Yeah, so in terms of what you'll see, so you'll be able to listen to a piece of content. You'll be able to turn this MDO processing on and off. And then, well, these aren't the speakers that we have in the room, but you'll see the kind of additional speakers that we have that we can then kind of turn on, and additional objects in the scene will kind of pop out of the stereo bed into these extra devices. Okay. So yeah, if you're interested in seeing that, then you can sign up for a slot here. We are going to ask you to give us some kind of feedback on what you think about it. We've got a kind of short questionnaire after the demo, so it's kind of really useful for us. The more people who sign up for that, the better. So we're going to try doing this kind of experimental system where we're going to try and use people's phones for the reproduction. But I guess before that, I don't know if anyone has any kind of questions or comments about the presentation.
I was just a bit surprised that you said that you get big efficiency savings possibly.
Yeah, I don't know if that's entirely true. It depends
60
on
audio objects.
I mean, potentially you've got okay, so the ADM format that stores a full channel of data, even if there's kind of silence in there. I mean, there's potentially, some objects in the scene might only be playing for like 10 seconds out of the entire production, so there could be efficiency there.
There's also the efficiency saving if you need to send, say, a football match in English and in Spanish, and you have a 5-channel mix of that. To send both languages in channel-based content, you might need 6 channels for each version, whereas you could send the crowd atmosphere in a 5-channel bed and then 2 extra channels on top, which has English commentary and Spanish commentary, so you save some channels there. So there are ways that it can.
And another thing that occurred to me is I've long been nagged by the listening experience in aircraft, where when you're trying to listen to a movie, then the mix between the language and the background sound in movies is typically not right, and so that would be an excellent application, I think, for that to get the equalization between
so
or that type of listening environment.
so like I say, we're looking at speech intelligibility, and also get how it's affected by external sources as well, and whether you can adapt a mix.
Just to kind of answer some of that question, someone at the BBC did do a study that was looking at using object-based and how people set the background-foreground sound ratio depending on ambient noise. So he was using cafe noise and I think train noise, but would equally apply to and was quite interesting because people have two strategies. Some people turn the background noise down so that they can hear the speech, and some people do the opposite. They turn the background way up to mask the external noise. So it's actually,
If you can individualize that,
well,
that would be
that's
fantastic.
one of the advantages.
Yeah, great.
Okay, so if there's no more questions, I guess we'll try this. So what people need, let's just see if this is still running to start with.
It came off of mine 2 seconds ago.
Your laptop has gone to sleep. But if anyone who's interested in giving this a go, if they can connect to, you should be able to see a Wi-Fi network called Seminar Wi-Fi.
So is that correct?
Then you should have the password is the same as the network name.
Is it worth turning the mobile data off?
It should be okay.
It works well. I've turned mine off.
I did as well because I knew that's what I was doing last time.
Just for like interruption.
Okay, then if you manage to get on that, if you can go to, so open up a browser and go to this this IP import, so 192.168.1.2:8000, and you should. I'm just giving away your pin to me.
Can you see that screen? That's being streamed as well, so everyone knows my PIN number at home, but don't worry, it's not important. But there's a screen which looks like that, is what you're trying to get to.
Yeah, so if you manage to connect to that Wi-Fi network and to this server, you should see that black screen that says NU. If you go to Maps, you should see a people.
Do you want us to join or not join yet?
Yeah, you can join.
So can your Wi-Fi deal with this many machines?
I don't know.
About 40 people trying to connect.
Yeah, it could kill it all in one go.
And if everyone who's managed to get on that, if you could make sure that the media volume's on your phone and turned up to max.
Turn it to 11.
Okay, so we're going to have a go at hitting play and see what happens. So we should get the kind of main scene playing out of these stereo speakers, and then anyone who's managed to connect should get some additional kind of objects coming out of their phone. We might just fall down though, so we'll see what happens.
There was ice everywhere. Thick ice and snow. And that's when I realised
It'll just loop round to the start in a second.
What should the screen be showing at the moment? I've got a 2 and a flashing.
That
Is it
means
flashing
you
red?
might be getting some audio.
Yeah, no.
Right.
No. Yeah, so I'm device number 2, does that mean?
Okay, so we might just wait. Need to wait for it to loop down.
Just loop
Right.
You get red or green flashing.
Pardon?
Red or green flashing. Or light.
It happened in the autumn forest, where the trees constantly shed comic green leaves, and there's always a chill in the air.
Brick. Got nothing.
Amelia and I loved it there. It was heaven for a year-old sense. Miles and miles of space to run around. Trees so tall and wide that we could chase each other and never be found.
Sorry, the service.
Right, we might just need to give. We'll just give it one more go. See what happens.
Just start the server.
Yeah. Yeah, we're just going to try connecting our devices first and see if we can get it working.
I got on, but I think the server crashed shit.
That was the first time I saw it.
Amelia!
It appeared as if from nowhere, staring at me.
That's not an object.
Might be a code though.
I faced it, looked at its gigantic black saucer-shaped eyes. Did the only thing I could think of. I stared back.
Hello?
And I swear, it smiled because its crooked mouth opened to show spiky teeth. Music came out. Music like I'd never heard before. As if its teeth had transformed into a beautiful string instrument.
Did you say they've tried this? Us trying to
Yeah.
maybe a little Wi-Fi router.
It was deep, and I couldn't swim. And the water was dirty, dark and dirty, and I knew that if I returned home with my clothes ruined, I would be in big trouble.
Everyone's gone.
And then something extraordinary happened. It lowered itself before me, gracefully. It stared at me as if to say, "Come on, climb up."
How many viewers do we have in the live stream?
It's gone. It went down to 2 now, so I think they just what's going on.
Okay, sorry, I don't think we're going to get this working in the room.
I've got a question from a live stream viewer.
Okay. It sounds amazing.
Yeah. Hi James. If you choose a home theatre room to investigate, what parameters do you most care about?
If we choose a...
Like a home theatre room to investigate, like using all of this, what parameters most are you looking for? I think more acoustically in the room. I think the question seems to be hinting at.
Acoustically, well, so we're quite interested in maybe not the room acoustics, but perhaps the quality of devices that people are using. So if we can, understand, the different quality of devices in terms of maybe their bandwidth, then we can do some intelligent kind of routing of objects there. So, for example, we might not want to put a dialogue into a mobile phone.
Okay, I hope that answers the question.
Yeah.
Damn it, James!
Do you think? Yeah, so I think that our Wi-Fi networking server's not working in this room, but yeah, if anybody wants to come down for the listening room demos, that's a stable system that we've got in there, and yeah, hopefully you'll hear something that you've never heard before. Is it different?
So we got a load of the BBC technology